Hey there, AP Statistics students, and welcome to our first video lesson. So this is how we'll probably be doing a lot of our asynchronous learning will be through some kind of video. So I'll make some, I think we'll have some from other folks, and we'll get a chance to see how this works. And when we meet either Monday or Tuesday this week, you'll get a chance to ask me questions and get some clarification on if there's anything that I hit here that we didn't quite get to or that you didn't quite understand. So I know that I've asked you to submit notes for this, and so today I think I'm going to use a PowerPoint presentation to kind of help us out with the notes for today. So our whole first chapter that we do, as I mentioned before, was chapter 4, because I really want to start start with the design of a study and then work our way through all the steps that go into making a study. So if you are titling your notes, this is samples and surveys. So once we've decided to do a study, we have to decide how are we going to get data for our study. And chapter 4 begins with looking at different possible ways to do that and some of the problems that can arise as we go along. So as you can see, there are 3 sections in chapter 4. We're going to do 4.1 today, and then our next video will do 4.2 and 4.3 as we start looking more into the language of experiments and using studies wisely. So let's take a look here. For 4.1, we've got several tasks or objectives. Here they are, learning the population and samples. So we're going to talk about the difference between those two. We're going to talk about some errors that we can make in our sampling procedures. So voluntary response samples, convenience samples. We're going to look at a table of random digits. That's kind of an old way to do random sampling, and we'll talk about what SRS means. It's short for simple random sampling. And then we'll look at a couple of other sampling techniques that we might use, and then finally explain some biases that we might show up, and we're going to have to come up with a definition for bias. So anyway, here's the key learning objectives for today's video. When we are doing a statistical study, okay, just sort of in general, usually the idea is to figure out something that's true about a population. So in a statistical study, the population is the entire group of individuals that we want information about. So I'm going to just use something that's kind of in the news right now. When we're doing a statistical study, a medical trial for a vaccine for something like COVID-19. As you may have heard, there's several vaccine trials that are going. And what we want to do is find out if that vaccine is effective for the entire human population on the planet. Okay, now that's not always going to be the case. It's not going to be the entire population of the planet. Some of the studies that we have seen recently are trying to figure out who's going to be elected our next president. Okay, in that case, the population would just be the United States of America. Okay, other populations, we might be doing a study that's trying to find out the opinion of students at Olympia High School. So our population would be the entire student body of Olympia High School. So depending on the question that's asked, the population of interest changes. And so we want to pay close attention to the wording of a question to see what the population of interest is. The sample, now that's the tricky bit, okay? Because sometimes we can't get data from the entire population. And as you see on the slide here, the sample is the part of the population that we actually collect information from. So in the case of the AstraZeneca trial that's going on right now, they've got a sample size of 50,000 people that they're trying to see if this vaccine is effective on. So that's a huge sample, but the population of the planet is so much bigger. Okay. When you look at a poll, a political poll, for example, on maybe who people are going to vote for the next president, well, they don't sample all the registered voters in the United States. They don't even sample 10% of them. Okay, sometimes the sample is as small as 800 voters. And you might think, wow, that's not very many to really get us a feel for the entire population of the US, but it probably is enough. So that's what the sample is. So in general, the idea is this: there's a population, and inside that, there's a subset of that population that's representative of the population. That's the sample. We collect data from that representative sample. And then we do something called making an inference. And I think on last week when we were looking at the syllabus, I talked to you a little bit about first semester versus second semester topics. And second semester I mentioned was inferential statistics. So that whole inference part, that's going to be mostly for next semester. All right. So when we start setting up our study, when we want to begin a statistical study, we start by saying, okay, what is the population we're interested in learning about? Okay. And then we say, okay, now what exactly is it that we want to measure? And then next thing we're going to say, okay, how do we choose a sample from that population? So as we begin our statistical study, whatever it is, those are the first 3 steps we're going to go through. How to sample is very, very important. Because remember earlier I said we want the sample to be representative of the entire population. If you sample poorly, then your population may have parts of it that aren't represented in your sample. And that can sometimes lead to erroneous conclusions based on your study. And I will talk just for a second about the 2016 presidential election, because there was a whole lot of sampling done about who's going to win the presidential election, right? And if you looked at the polling data, there was pretty strong evidence to suggest that Hillary Clinton was going to win that presidential election, okay? But as we found out, on election night, that's not how it went down, okay? It wasn't Hillary Clinton, but rather Donald Trump that became our next president. And how did that happen? Well, some people think that there were people maybe who lied in the sampling, and that's possible, but that's always true. Okay, I think what happened was there was this thing that they talked about then, was the hidden Trump voter. That when they did the sampling, the procedures didn't allow them to really find all those Trump voters who wouldn't respond to their sampling methodologies. Because how do they get a hold of these people? They call them on the phone. Okay, and there was a lot of folks who won't answer that phone. And apparently, there's a lot more of the Trump supporters who wouldn't answer their phone than Hillary Clinton supporters. So we created a situation where the polling data showed one thing, but the actual population, so the population went a different direction. And so we have to be careful when sampling that we make sure our sample is representative of the entire population. So one way to do it incorrectly would be something called convenience sampling. And this is literally just picking who's easiest to get a hold of. So my example for this a lot of times is, suppose you're doing your end of the year study, and if we were on campus, let's say, and you were like, okay, I need to collect data from OHS students, right? That's my population is all OHS, but I want to get data from just OHS students. And you're like, I'm just going to ask the people at the lunch tables around where I eat lunch. Okay, it's a great example of convenience sampling. Okay, it's easy for sure. But there's some question about, would that sample truly be representative of the entire population of Olympia High School? I'm guessing probably not. So convenience sampling can be a bit of a problem. It's going to show something called bias. And now we have to define bias in a statistical sense. Now, I know that a lot of you have probably have a definition of bias that you've used in the past. And it's become kind of a big topic, because when we look at like racial injustice and systemic bias or systemic racism that exists in some of the systems within our country, our city, our state, our school, what we're really talking about is a bias there. Statistically, we have a sort of a different definition of bias, but I don't want to devalue that idea that there are biases that exist. The racial one has certainly been forefront in the news for a few years. But what we're going to define it to be is that just the way that we did our sampling, it made it so that there was a systemic, again, there's that idea of being systemic, a systemic reason that our people in our sample, or our subjects in our sample, choose one outcome over the other. And that's how we're going to define bias. So that systemic favoring of one outcome over the other can create a bit of a problem for us, because once your study has bias in the data, it does not matter what we do from there on out. There's no fancy techniques I can teach you statistically that can help correct for a set of biased data. So this first part of your study is really essential, as we'll see later on. If you start with biased data, then essentially your study is worthless. And I think we'll see exactly why that is coming down the road. Convenience samples are pretty bad. Voluntary response bias is another example of a study or a sampling procedure that can create quite a bit of bias. So in this particular scenario, what's happening is people can choose to respond to your study. And when they choose to opt in, they could do so for a variety of reasons. Typically, this is where people with a strong opinion will be the most likely ones to jump into your study. And the people who are just kind of like, meh, don't really care, aren't going to respond. And that's an important part of the population, but you won't sample them if you do voluntary response bias. The example I use a lot is if they try to pass a measure on gun control. Okay, there's been lots of attempts to try and control the kinds of guns that are available to people in the general public. And whenever one of these things comes up, if they put out a poll like, hey, I think the example that the book uses, like, we're going to do a telephone call-in poll. If you are in favor of this new regulation to regulate the kinds of guns that are available to the general public, call in and press 1, and if you're opposed, call in and press 2. And you can just imagine how quickly the folks who oppose any kind of restrictions on gun ownership will call in and respond to that, because of very strong opinion about that. Similar, there's all sorts of similar opinions that people might have that when they carry them, they're very strong. And so they're the ones who are going to respond. And that creates a bias in your study. The thing about bias, when you're identifying bias in a statistical study, okay, in all of these examples, we have bias. When you're identifying it, you have to identify the source of the bias. Okay, so why is it bias? And you have to identify the direction of the bias. So for example, in that gun control one, I would say that because of the voluntary response bias, people who have a very strong opinion are going to call in. And we've seen over the past that it's really the people who oppose gun ownership, people who are going to press 2 that they oppose that, are going to respond more often. So our study will be skewed to the side that opposes the new regulation on gun control. So how do we do it so that we don't have any of these issues? And that's a good question. The number one way, the method of sampling that's most likely to reduce or eliminate bias is simple random sampling. Okay, random sampling is just making sure that we use some sort of random number generator. A simple random sample, there's 2 parts to that. Every single individual in the population has the same probability of being selected. Okay, and every sample of size n, whatever that lowercase n is has equal probability of being selected. So those are the 2 parts that have to be there for a simple random sample. Now, most of the time, when you have to do a simple random sample, it's pretty easy. There's a couple of different ways to do simple random sampling. I'm a big fan of, if you have like a class of 35 statistics students, let's say, like we have, then I just put everybody's name in a hat. Okay, put all the names in a hat and then draw out 5 names. Okay, and if you ever have to describe a randomization, that's a perfectly acceptable way to do it. Your calculator has random number generation on it, so you can do random numbers on there. There's a great website called random.org, and it does all kinds of cool random stuff for you. So you can use random.org. Computers are great, and there's also a random number table. So if you go into your textbook and you flip to the back, table D in the appendix is a random number table. And while this is kind of kind of an old way of doing a random sample. It still gets assessed on the College Board exam for some reason. It still could be used if that was the only thing you had. So, you know, if you're ever stranded on a desert island and need a random sample and all you have is your textbook, well, then there you go. You'd have a way to do it. But I'll show you here how to use the simple random sample table. But just know that in practice, in real life statistics, we just use a computer. So what we do is in the random number table, all the digits 0 through 9. So all of those digits are just randomly on the page. Okay, now it's organized into columns, but that's just so your eye doesn't get overwhelmed by it, because a solid page of random digits would be quite overwhelming to the eye. And then you just randomly pick a starting spot, and then you go from there. And if you have 500 people in your study, you do groups of 3. If you have 50 people in your study, you do groups of 2. If you only have 10 people, then you just use the single digits 0 through 9. You're gonna go across the table then once you pick a random starting spot. So, and let's see, how to choose simple random sample using table D. Well, you number everybody, and then you go across from a random starting place on table D. And here's a section of table D. This is what it looks like, highlighted in blue there. Oh my, the formatting of the table here looks a little crazy, but that wasn't supposed to look like that. But anyway, if you go to your table D, you'll see that line number 130 looks something like this. Okay, and they've numbered the hotels, and they're not in order here, but they're 2-digit numbers. And so what we would do is we would start at the beginning of table 130. Now, normally you would randomly choose where you're going to start. I should say that, but they're going to tell us where to start, so we all get the same random numbers. And then you just go across in groups of 2. So obviously your first 2-digit number there was 69. Your next one was 5, then 16, then 48, then 17, 87. You can see how we're just going across. Okay. But the highest number of our hotels here, I think, is 30. So it's hard to see. I think it's behind that blue thing. So obviously, like the first number, 69, is way too big. So we're not going to use that one. We'll just throw that one out. Okay. 5, that's in our sample. So yeah, we'll take 5. That's good. And that's, oh boy, yeah. I'm sorry, guys. The alignment here just isn't working out, but you get the idea. 16 would work. 48 would not work because that's above our sample. 87 or 17 would work, and then 87 wouldn't, and so on and so forth. The font is obviously screwed up here. Wow. All right, I apologize for that, guys. I'm using a different piece of software because PowerPoint doesn't work on my computer right now. Sorry, but you get the idea. Just looking at the 2-digit numbers, the ones that we would use are the ones that fit in our numbering system. So, all right, and then we wouldn't use any of those. You get the idea. All right. So our simple random sample of the 4 hotels were going to be 5, 16, 17, and 20, because we had all those other ones that were too big for us. Okay. That is how we use a simple random sample from the random number table. And that is basically the best way to do sampling to remove bias, or to try to reduce or eliminate bias. Can't really always get rid of it, but it's a pretty good way to get rid of a lot of it. Sometimes there's going to be bias in the population, and we want to draw that out. We want to understand what that impact is going to be. And so if there's really important characteristics within there, okay, like inside the population, there might be groups that are really different. We might want to understand how they all have differing opinions. That would be a different kind of sampling. And so I'm actually going to jump out of the share here for a second and go to my virtual whiteboard. Oh, except I lost my mouse. Where is it? Okay. There it is. And I'm going to show you an example of what stratified sampling looks like. Okay. And I like to use the college dormitory example. Okay, so I'm going to draw a college dormitory here. Okay, there's our dorm. And in our dorm, we've got some different floors, and I'm going to draw different floors. Oops. Maybe I'm going to draw different floors. Okay, we got the top floor. We've got next floor. I'm just going to give us a few floors here in the dormitory so that we can kind of take a look at stratified sampling here. And then we'll use the dormitory again for another example here in a second. So, and sorry, I should have had that ready to go at the beginning, but in case you didn't notice the change in outfit, oh no, the change in outfit, I'm actually back here doing this on a separate day. I had a little issue there with the previous second half of the recording. So, all right. So here's our dormitory. And you can see we've got our floors. We've got we've got the first floor here. First floor, second floor, third floor, fourth floor, fifth floor, sixth floor, and of course, top floor, penthouse, seventh floor. All right, and the dorm council, okay, there's such a thing. There's a dorm council. You'll find that out when you get there. Has decided that this is a dorm that's located up here in the Great Pacific Northwest, and we want to be environmentally friendly. And so we've decided that in order to save energy and to cut down our greenhouse gas emissions and our carbon footprint, we don't want to use electricity to run elevators. So we've decided we're going to turn off the elevators. And we're just going to have stairs. Everybody's college kids, they're in shape, so we're gonna turn off the elevators because we think that's a good idea. And we decide that we're going to go out and we're going to see we're going to take a quick opinion poll of the folks that live in the dorm. Do you think that based on where they live, people are going to have differing opinions of this idea to turn off the elevator? Yes, they will. Obviously, right? The folks who live on the seventh floor are probably going to have a very different opinion of the idea of turning off the elevator than folks on the first floor. And so in order to gauge public opinion in this particular case, the entire population being the residents of the dorm, what the student council or the dorm council decides to do is do what's called a stratified sample, meaning what they're going to go to each floor, okay, and they're going to sample a SRS from each floor, okay. Maybe randomly choose, let's say 5 people from each floor. That's a stratified sample. We recognize that there are these strata, these characteristics inside the population that might impact how they would respond. In other words, the people on the 7th floor are going to have a bias towards keeping the elevators on. Okay, probably people in the 4th, 5th, and 6th floor are going to be right there with them, right? So those folks in the upper floors have a bias towards keeping the elevators on. And we want to see just maybe how strong that bias is, okay, or recognizing that that bias exists. And so therefore, that becomes an important characteristic. And so we do what's called stratified sampling, randomly sample within each one of those strata. the end result will be that, yeah, we have a pretty different opinion probably from the 7th floor to the 1st floor. And that's what we call stratified sampling. So, all right. Uh, our our next sampling procedure, sorry, I want to get back to the slideshow here. And just say, first classify the population into groups of similar individuals, that's the strata, and then choose separate SRS in each of the strata and combine them to complete the full sample. That is stratified sampling. Okay. The cluster sampling. Okay, so there's another kind of procedure. And we have, for some reason, we recognize that there are groups in the population. And maybe it's because it's a really big population, they're all over the place. But within the population, we recognize there are these subsets that are pretty much representative of the entire population. Okay, in that case, each cluster is pretty much the same as another cluster. Then you could just randomly select a different cluster or a couple of clusters and randomly sample them. So cluster sampling is a little bit different because we recognize that there's different sections of the population, but we figure they're all pretty much the same. And I like their example here. They have the stage, and they have 9th, 10th, 11th, and 12th graders that are assigned seats in here. And they said, okay, could you use the same group to do different kinds of sampling? And we could, right? I'm going to go back to my dormitory example and do the same idea, is use the same setup, but we're going to look at oh yeah, we're on the whiteboard. Okay, good. We're going to look at how we could do this other kind of sampling procedure. So it's not going to be stratified this time. It's going to be cluster sampling, but I'm going to use the same image. Whoops. Okay, so what we have here is a co-ed dorm. So each floor has a random selection, and there's men and women living on every floor. And this time, though, the question is not about turning off the elevator. Okay, the first floor actually doesn't have residents on it. The first floor in our new example has the dining hall. It's down here. Okay, so, and in the dining hall, a very important issue has come up. What kind of breakfast cereal should we keep in the or make sure that the dining hall always has? Okay, so now, assuming that there's equal mix of genders on each floor, 2 through 7, that each floor then basically is a copy of each of themselves, okay, then it doesn't really matter what floor people live on. Each floor is sort of equally representative of the entire population of folks who live in this dorm. So in cluster sampling, what we would say is, hey, these clusters up here, they're all pretty much the same. Everything up here, oh, I was writing with white pen. That's great. That's not going to work. These guys are all pretty much the same up here. So if we identify those as our clusters, then what we do is we randomly pick one floor or 2 floors, and we just sample everybody on those floors. And that's what cluster sampling is going to look like. So maybe, if we had a random number generator, okay, I've got one over here, and on my calculator, if I just say random number between 2 and 7, and the first one it gave me was 5, and then it said 3. So I would just go to floor 5, go to floor 3, and sample everybody in clusters 5 and 3. And that would be our entire population represented by those 2 floors. And that's what cluster sampling is. So we have seen a lot of different things here. Let me go back to the slideshow here and we'll kind of summarize here at the end.